All right, lesson 113, direct and inverse variation. You guys are going to see this a lot in Algebra 2, all right? So make sure you follow along. So you want to write down direct variation, and anytime you read that something varies directly, that means you're going to use this formula, y equals k times x, okay? Where k is a constant that we're going to find. Okay, direct variation is constant growth. So for example, the mass of a substance varies directly as the volume of a substance. So instead of using y and x, we are going to use variables that relate to the words that they give us. And it goes in order of the sentence. All right? Mass varies directly as volume. So we're going to write, instead of y, m. We're always going to use k for the constant. And then it varies directly as volume instead of x. Okay? So y equals kx is your general form that you're always going to think about when you see varies directly. But then use the variables they give you, and it goes in order of the sentence. Mass, then volume, and you're always going to have k. Okay? If a mass of 30 kilograms of a substance has a volume of 6 liters, okay, so they're going to give us 2 points to plug in that will help us find k. All right? So they're going to give us one set of numbers to give us k. So if a mass of 30 kilograms of substance has a volume of 6 liters, that means 30 goes in for m, and 6 goes in for v. Okay, the reason they give us those points is simply so we can find k. All right, so go ahead and divide by 6, and now I know that k is 5. All right, so we go back up to our top equation, and we substitute in k. That means no matter what, for the rest of the problem, mass is always equal to 5 times the volume. All right, so now it says, what is the volume of 65 kilograms of the substance? What is the volume? So we're solving for this, which means this is the mass. Okay, so 65 goes in for m, and now we're going to find volume. Divide by 5, and we get 13. Good. And you want to go back and see what your volume units is, and it would be liters. Okay? You should always have 6 steps. Don't skip any, okay? 1 is the equation. 2, you plug in the points they give you. 3, you solve for k. 4th step is to plug it back into the equation. 5th step is to plug in the new point and the answer. 6 steps, all right? Don't skip any steps. Let's try it. Okay, under certain conditions, the pressure of gas varies directly as the temperature. All right, so pressure varies directly as temperature. That means we're going to do P equals K times T. It's always K times when you see varies directly, all right? All right, so that's first step is the equation. Now we plug in the points they give us. When the pressure is 1200 pascals, the temperature is 300 kelvins. All right, so when the pressure is 1200, the temperature is 300. Now we solve for k. So divide by 300, divide by 300, and that gives us 4 for k. Okay, next step is to just plug k back into your original formula. So P, pressure, is always equal to 4 times T, which is temperature. Now plug in the last part they give us to answer the question. What is the temperature when the pressure is 300? So 300 equals 4 times T. Divide by 4. And what is that? Okay. So temperature, again, make sure you put your units, is in kelvins. 75 K for kelvins. All right, now we have inverse variation. So when you see the word varies directly, you're doing k times your variable. When you're doing inverse, it's k divided by your variable. So if something varies inversely, as one thing increases, the other thing decreases, so it's division. All right, under certain conditions, the pressure of an ideal gas varies inversely as the volume. So when you read these words, you have to know k divided by. So it goes in order of the sentence. So this time we have pressure, and we're comparing it to volume. All right, so instead of y and x, we're going to use p and v. So p is equal to k divided by v. So when you're doing inverse variation, you always have k in the numerator here. Okay? This is always varies inversely. All right, now they're going to give us a point, just like the last one. So when the pressure of a quantity of gas is 9 pascals, the volume is 100 liters. All right, so we have 9 that gets plugged in for pressure and 100 for liters, which is our volume. Okay, now we're going to find K. In order to get K by itself, we have to multiply by 100. This cancels. And multiply by 100. So our constant is 900. Okay, then we always go back to the original equation and plug in K. So pressure is always equal to 900 divided by volume in these problems, or in this problem, okay? What would be the volume if the pressure increased to 20 pascals? So now I have pressure as 20, and I want to find the volume. How do I solve when there's a variable in the denominator like this, Isaac? I would cross multiply. So put this over 1, and now I have 20V equals 1 times 900, so that's 900. And then divide by 20. So V is equal to 45. And you want to go back up and check your units for volume. And our units for volume is liters. Okay? So every time you have 6 steps on these. So let's try one more for varies inversely. Okay, so varies directly is k times x. Varies inversely is k divided by x, depending on what your variables are. So for this one, we've got under certain conditions, the pressure of perfect gas varies inversely as volume. Raise your hand if you can write that equation for me. Monica. Good. All right. When the pressure of a quantity of gas is 7 pascals, the volume is 75 liters. Raise your hand if you can tell me what the next step is, Julia. Okay, yep. Now we have to solve for K. Josh, what step would I do to solve for K? Okay, yep, times by 75 over 1. So 7 times 75, who has that? Anybody? Thank you. 525. All right, the next step, we just substitute it back in. So Nico, what should I write down? Good. All right, what would be the volume if the pressure is increased to 15 pascals? So Jordan, where's the 15 go in? What did you say? Good. Okay. And then we've got V in the denominator, so we're going to have to cross multiply to get it out of the denominator. And somebody got me on this one. 525 divided by 15. Isaac. Thanks. 35. And this one was liters, right? I gotta go back up and look. Yep, liters. All right, 35 liters.